Hi, Assalamualaikum, and a very good evening. So this is our teammate. We are from Group 9, Section 1. First one is Anishuhada binti Halim, the matrix number CE210234. Intan Shafika binti Shukri Effendi, EE210021. Nur Shaira binti Muhammad Saleh, DE210050. And lastly, which is me, Raimi Nadira binti Bahrom, AE210040. So our topic for this assignment is memory access, microprocessor, and microcontroller programming. For the introduction, we are given the technical specification architecture of ARM Cortex-M3 programmer model, ISA and Kale Microvision software. We need to organize process to access memory using flowchart, compute program based on proposed flowchart, analyze the program functionality using debugger Kale Microvision, and capture the simulation results to indicate the accomplishment of the problem solving. That's all from me. Thank you.
Must us to do a copying data from a program memory to us RAM. So as you guys know, this is our coding project. This coding explains the purpose of each section, which is area assignment group 9 and code read-only has defined the start of the program memory. Export is to export the main function. The entry coding is define the entry point that copy data from memory to SRAM. So for the next, we need to use n. N is the end of the program. So we back to the main function. The main function we have here is movw, move toward move t. MOVT is the load base address for program memory and SRAM. So for MOV is to initialize a counter variable as you can see in this programming. Okay, so L1 is labeled for loop 1. So LDR here have content for R2 which is R0. Content in R0 is adding into the R2 is load data from program memory R0 into the R2. So LDR and STR is load and store data between memory location. Add stand for increment the counter variable. As you can see, the content in R1 is added into the content into the R2. So 4 is basically like our constant value, which is CMP is compare the counter with a threshold value. We compare all the value here into the threshold value. So the B and E value for the loop 1 counter is not 0. As we can see is loop back if counter is not 0 has end the process. So for the executing flow, we ask know a visual representation of how data is transferred from program memory into SRAM. So this is the basically explanation for the loop mention. So for the recap of this coding, the memory address transfer data in loop execution is emphasized the importance of memory operation is embedded the system. This also gain the efficient data handling for optimal performance. So as you can see, this is the coding for the reset handler. Reset handler via proc, export, import, LDR, BLX. As you can see, LDR, BLX, and LDR, we have here, we store all the program into the R0.
For this coding, get the system LPC, we get this like this, and start up LPCs like this, and this is the result for the register. Next is 000 for BA. And for R1, R15 PC, and XPSR 0x 000004E6 400 FC104. This is the memory. The correctness of the data. The correctness of the data verify that each word of data from program memory is accurately transferred to the corresponding frame address, confirm to the transfer data match the expected content, which is the SNIDE might be a sequence of data stored in program memories, which is this register and this memory 0x00000080. The loop termination is confirmed that the loop termination correctly after all data has been transferred, preventing any unnecessary iteration. Verify that the loop termination condition CMP-R3, the hashtag 26, accurately detect when all data has been transferred. The error, which is the output, is check of potential errors such as memory access, violation, or unexpected behavior during data transfer. Ensure that the code handle each case appropriately, such as reaching the end of program memory or SRAM. The simulation result step through the code and offset the execution flow, memory content, and register value. You ensure correction. For this memory one, we just start with address 00000080 until the 00000224. The performance consolidation evaluates the efficiency of the code in terms of execution time and resource utilization. Assess whether optimization can be made to improve performance, such as reducing the number of instructions or optimizing memory access pattern.
Hello and hi, my name is Nushaira binti Muhammad Saleh with metric number DE210050. Okay, so I will conclude the presentation. Okay, so in conclusion, the development and validation of the assembly code for transferring data from the program memory to SRAM represent a significant achievement in embedded system programming. So through a systematic approach, algorithm design, code implementation, and base simulation validation, so a robust solution has been created to efficiently handle the data transfer operation in embedded system. So the successful execution of assembly code demonstrate its effectiveness in achieving precise control over memory, manipulation, and optimized resource utilization. So by leveraging assembly language programming and CAD tools like we use scale U-Vision, so we can ensure that the correctness and reliability of data transfer operation crucial for various embedded system application. So moving forward, the development solution serve as a foundation for further development integration into real-world embedded system application or projects. So continuous refinement and optimization may be necessary to address specific application requirements and platform constraints. So after all, the demonstrate the capability of assembly code lays the groundwork for future advancement in embedded system development, so contributing to the advance of technology in innovation in various industries. Okay, so that's all from our group. Thank you.